Hello friends, welcome to Susan and John MathTube. So, in this video, we are going to continue our journey in complex analysis and finally we have reached complex integration. So, in this video, we will learn how to evaluate line integrals. But in the next video, which is going to be extra important, we will cover all these things together, Cauchy's integration techniques. And then we will talk about singularity and we will complete Cauchy's residue theorem. And finally, there are three types of integrals in evaluation of real and improper integrals. And after that, we will jump to set transformation. Okay, let's start. This is going to be like really easy if you remember line integrals in vectors. In vectors, we are dealing with 2-dimension and 3-dimension, but in complex, it will be always 2-dimension. So we have a complex integral and a path is given. So this is exactly how the domain looks like. Do you still remember? The domain is the z plane. That means the input is xy. And the range or the output will be the w plane. That will be denoted by uv. Anyway, we will focus only on the input plane for the time being. So the input is from z equal to 0. Z equal to 0 means the coordinates 0, 0 or 0 plus 0i. So this is our initial point. And the final point is 1 plus I. That means z equal to 1 plus I or the coordinate 1, 1. So let's say 1, 1 is here or the complex number 1 plus I. Now the next thing is we have to integrate. What do you mean by integration? Integration means addition, summation, continuous summation. And you can see that we can reach from 0, 0 to 1, 1 through a line. We can use some random curve and reach this point. Or you can use a parabola. Or you can use a circle. There are many ways in which you can reach 0, 0 to 1, 1. But in this question, they are asking you have to travel from 0, 0 to 1, 1 using the path y equal to x. So the path is given. It can be a parabola, it can be a line, it can be a hyperbola, it can be any random curve. But in this question, they have given y is equal to x. Now let's do it like super quick. The method is like very easy. All you have to do is you have to convert everything in terms of x or in terms of y. So what we do is we will assume z equal to x plus iy. I told you long back in video number 2 or in the third one that every complex number in the domain will be taken as x plus iy or r e power I theta if you want it in the polar form or the circular form. Now I am taking the differential dx plus I dy. Now using this path in this problem to problem, now it will be different. So z will be equal to x plus ix and dz will be equal to dx plus I dx. So dz will be dx common and 1 plus I. Now plug all these things into the integral. So capital I equal to, once more, let me make it very clear. It will be nice if you remember vector integration. We used to change everything in terms of x or everything in terms of y. So similarly, I am trying to convert everything in terms of x. So the starting point is 0, 0 and the end point is 1, 1. So can you see that the x coordinate moves from 0 to 1. That is how I got 0 to 1. X square plus I multiplied by, my job is to convert everything into x. So this will be x and dz we already evaluated 1 plus I dx. Can you see now this is a very simple integral. By the way, how do you integrate, not related to this, but how do you integrate 7 multiplied by x square? You will take this 7 outside and then integrate. How do you integrate 7 multiplied by sine x? You will take this 7 outside. So similarly, this is complex integration and 1 plus I is a complex constant. So I'm going to take this 1 plus I outside, and that leaves me with x equal to 0 to 1 x square plus ix into dx. And now it's just ordinary integration. So I will be equal to 1 plus I. What is the integral of x square? X to the power 3 by 3 plus I is a constant. Don't forget, every complex number is a constant complex number. So it's a constant when you integrate. So this will become x squared divided by 2, x equal to 0 to 1. Upper limit, lower limit. When you plug in upper limit, it will be I is equal to 1 plus I multiplied by 1 by 3 plus I into 1 by 2 minus 0 plus I into 0. Now you can use a calculator. I will recommend not to waste time. Most of the scientific calculators will allow you to multiply complex numbers, divide complex numbers. Now if you don't want to use a calculator, you can use the classic method. 1 multiplied by 1 by 3 plus 1 multiplied by I by 2. Anyway, I'm not going to recommend that method because as an engineering student, you should use technology. So the answer will be minus 1 by 6 plus 5 by 6 I. Okay, so let's go for the next question. Now, I feel that you understood the method a little bit. Now let's polish it. Okay, so I have a problem in which I want you to perform this integration in 3 different methods. By the way, for the students who do not remember integration, I'll put it like this. Long back in your high school, you learned something called real integration. For example, you might learn how to integrate from 1 to 3 x square multiplied by dx. And this is called a real integral because you are allowed to take input only from the real axis. And in this question, you are allowed to use any number that comes in your brain between 1 and 3, starting from 1 to 3. 1.1, 1.001. So basically it's an infinite process. There will be infinite number of numbers. And this integration symbol is nothing but the letter S or the long S, which used to be in the English alphabet long back. This notation was brought by Lebany, a mathematician who is a co-founder of calculus. Newton and Lebany both are credited for calculus. Anyway, so here there are infinite number of points. Now look at this. In real integration, you had only one option. You had to move like this. But right now we are learning complex integration. So when you move from one complex number to another complex number in the domain. Now look at this. This is the domain and this is our range. So suppose I consider 2 points in the domain. You can reach point A to point B through infinite number of paths. That is why we are going to integrate this in 3 different ways, and we might get 3 different answers provided the field is not conservative. Okay, now let's go for part 1. So can you see we have to integrate from z equal to 0. 0 means 0 plus 0i, and that will be the coordinate 0 comma 0. To z equal to 1 plus I, that means 1 comma 1. Now first they are asking line joining. Now look at this. Whenever they ask you to use line joining 0 0 to 1 comma 1, or let it be any coordinate, they are not going to provide the equation because you learned this equation in your high school. The equation of line joining two points is y minus y1 equal to gradient. Gradient will be change in y by change in x multiplied by x minus x1. So I have x1 y1, x2 y2. Apply the formula, you will get y equal to x. And then you use z equal to x plus iy, dz equal to dx plus I dy, plug everything there. And this is going to be like super easy. I'll write this integral. So we have I equal to integral z equal to 0 to 1 plus I x minus y plus I x squared dz. Now I'm going to convert everything into x. If you want, you can pause the video, try it. If you want, you can convert everything into y and try it. But the last answer should be the same. Anyway, I am going for the first option, converting everything into x. So I use the limit of x, and wherever I see y, I'll convert it back into x using the path. The path I just evaluated, y equal to x plus I into x squared, and this will become dx plus I dx, and this will come common. Cut. This I is going to go outside, and this there will be 1 plus I here, and I'll get x equal to 0 to 1 x square dx. I'm skipping steps, try it yourself, and at the last your answer should be minus 1 by 3 plus 1 by 3 into I. Okay, now let's go for the second part. Evaluate the integral, but now can you see the path is different, and you know this path is a parabola. So now they want you to integrate the same stuff, and the starting point is same, the end point is same, but they want you to integrate using a parabola. And what do you mean by that? It means the domain will contain every point that you see on the parabola, and corresponding to every input complex number there will be an output complex number, and it will create something else. We are not bothered about that, but we are adding the sum of all the output complex numbers. Now let's go for the method. That's exactly what you need in the exam. So I is equal to integral. I'm going to convert it into x equal to 0 to 1, and x minus, what will I write instead of x square? I think you copied the question. Can you see? Y equal to x square. So x minus x square plus I x square multiplied by, look at this, z equal to x plus iy. That means z equal to x plus I into x square. So dz equal to dx plus I into 2x dx. So dz equal to, I'll multiply this by 1 plus 2ix into dx. Now slowly open the bracket, open the bracket, open the bracket. I'm not going to do that. It'll be very nice if one of you can do this, or you comment below this, so that it will be useful for everyone. I want at least 2-3 of you to complete this and put the comments below, so that it will be useful for other students. Okay, let's go for the third part. So the third part is very easy. It is given in parametric form, and whenever it is given in parametric form, I am going to convert it into the parameter. And good news, look at this. If I am converting it into the parameter, I have to remove x and I'll put t. I will remove y and I'll put 2t minus t square. That means I want the limits of t. But look at this, t and x are the same. So if you move from 0, 0 to 1, 1, that means x is moving from 0 to 1. And since x and t are equal, t is moving from 0 to 1. So I will just give you a hint. You convert everything into t. So t varies from 0 to 1. And instead of x, you can put t. and instead of y I have to write 2t minus t square. So minus 2t plus t square plus etc etc etc. The answer will be minus 1 by 3 plus 1 by 6 into I. It will be very nice if you can try this and comment below whether you got the same answer or not. Now let's go for more serious problem. Till now what we did is line integration. By the way, line integral does not mean it should be a line. It can be joining two points through a curve. Now comes contour integration. Contour means a closed curve. So look at this. Contour means a closed curve. Usually in your examination they can ask maybe triangle or a rectangle. If they ask a rectangle, then it is headache because you have to integrate 1, 2, 3, 4 times. Just like we did once, we have to do 4 times and add them up. Anyway, I'm going to give you a very simple contour. Now before we start, I'll show you that contour. It is a circle. It's a closed curve. So I want all of you to note these things. Do you remember this? The circular coordinate, the polar coordinate. So this is equal to this. So if you ever see mod z equal to r from now onwards, remember z can be replaced with r e power I theta and vice versa. And in a circle in polar form, theta will vary from 0 to 2 pi. So the question is like this. Consider the circle mod z equal to 1. You have to memorize this part. Mod z equal to r is a circle with center, origin and radius r. Mod z equal to r, I introduced you to this thing in Lorentz series. Mod z equal to r is a circle with center, origin and radius r unit. So we have a circle over here, center, origin and radius 1. And you can see infinite number of points in the circle, and corresponding to every coordinate you will get another coordinate, and we are adding all those things by using the function log. Anyway, that's a theory, but we are not going to use the theoretical method. We will go for a technique. So the technique is very easy. Z equal to x plus iy. No. Wait a minute. Whenever they give circle, logarithm, z to the power n, do you remember long back itself I told you? The polar form will be easy. So I'm going to convert this into polar form. Mod z equal to 1. Therefore, z equal to 1 into e power I theta. Maybe some of you are confused. Don't worry. Now we are going to do a lot of problems related to this type of contour. Anyway, for the time being, note it down. If you see this, you can write this. If you can write this, you can write this. They are equivalent. So that gives me the derivative dz equal to e power I theta d theta multiplied by I. I hope I kept I here. Yeah. This is a general one. Here the radius is 1. So look at this. We have integral over c log z dz. So I'm going to convert everything into theta. So theta varies from 0 to 2 pi. Logarithm of e power I theta. And dz can be replaced by I e power I theta d theta. Now look at this. This is a very simple integral. What is log a power b? Can anyone tell me? Yeah, b multiplied by log a. What is log a power b? B multiplied by log a. So we get theta is equal to 0 to 2 pi. Can you see log a power b? So this I theta jumps here. Log e. What's log e? 1. Log e is 1. Multiplied by I e power I theta d theta. Now again I am going to ask what is I square. I square, if you remember, is minus 1. So the integral is going to be negative theta is equal to 0 to 2 pi. Log e is 1, that's gone. So theta multiplied by e power I theta d theta. Now I want you to remember Eilate rule. You remember integration by parts or the shortcut called Bernoulli's rule. So we'll apply Bernoulli. If you want, you can apply integration by part, but I love Bernoulli. So first function e power I theta divided by I. If you don't remember Bernoulli, you can just check the videos in Fourier series. I have kept it in the playlist. And in the first video itself, you will see this Bernoulli being used there. Minus the derivative of theta is 1. And again you integrate this stuff, e power I theta by I squared. Once more, a student who is learning complex analysis is supposed to be very good in integration. So I'm sure that most of you are like very familiar with Bernoulli's technique. If not, I'll recommend you to pause this video and watch Fourier series. So theta is equal to 0 to 2 pi. Now what is I square? I hope you remember 1 by I is equal to minus I. And I square is minus 1. Applying all those things and taking common. Minus e power I theta comes common. And this goes up. It becomes minus I theta plus 1. And we have to apply theta equal to 0 to 2 pi. One last question. If you can answer, it will be very nice. What is e power I theta? We learned in the first video in complex, polar form. This is cos theta plus I sin theta. So what is e to the power I into 2 pi? That will be cos 2 pi plus I sin 2 pi. Let me give you one warning. In case you did not remember this, it means your basics are not that good. So I'll strongly recommend for such students, pause this, watch the first video in complex numbers, complex analysis, the first video. Make the base perfect and come back and learn this. Now I'm going to apply this theta value, and at the last I'm going to get 2 pi I. By the way, cos 2 pi is, you can use a calculator, 1 plus I multiplied by 0, that will be 1. Okay, so I'll be back with a very important video, and that will be Cauchy's integration techniques. There are total 4 techniques that we have to learn, but in the next video we will learn 3 techniques. And then we will talk about residues, and finally we will learn application of complex integration. So till then, my friends,